and to be able to present some of the work looking at Kenya and the bird distribution in Kenya and the change that have happened over the last 50 years. So as many countries in Africa, things have been changing in Kenya. And for once, the population has been dramatically increased from around 10 million to now 50 or more, 55 million people. And that's a lot of more people in the country. And at the same time, is this working? Yep. At the same time, the temperature also been increasing by roughly 1 degree. And these two trends arguably are at the origin of many changes in the landscape. And they might be linked together, but I like to think of them as two separate fundamental change in the landscape. And indeed, deforestation has been growing in Kenya as people needed more wood for construction and for cooking. At the same time, urbanization has been increasing a lot with a lot of landscape that have been transformed into urban area now. Soil erosion has also been a big challenge in the country with degradation of the forest, that leads to bad soil erosion. And also monoculture with the change in type of agriculture, although maybe not as bad as in, the Northern Hemisphere. There's still big plantation happening with a big impact, obviously, on biodiversity. And finally, water pollution that is kind of, at the end effect of a lot of these processes. But water pollution is a really big challenge also in Kenya. And I believe all of these challenges are the case in all of Africa and probably around the world due to the two trends that I've highlighted. And in the middle of all these changes, the bird have been evolving and the bird have been changing, adapting to the landscape. But how exactly each of the species have been adapting, that's not really well known or quite difficult to study over such a long time range. Actually, I'm saying we don't really know. That's not exactly true. There's a few species. Some of you will recognize these species that have received vulnerable or even critically endangered or endangered status by the IUCN, and that led to funding and further research on these specific species. And we've thankfully, thanks to this status, we've been receiving funding to be able to study these species more particularly. And one example I like to give is for this Malagasy pond heron that we thought was a pretty rare species in Kenya. And then in 2004, I believe, there's been funding received to do some surveys. And on the 24 site, if my memory is correct, on the 24 site that was surveyed, there was 12 new sites with the pond heron discovered. And that just highlights how, it's not like we didn't know, it's not like the bird wasn't there. It's just we didn't know where it was. And thanks to this, status, we've been able to know that the species was actually a lot more widespread in Kenya than we thought. And the breeding record in Madagascar show a very dramatic decline in the species, while we actually seeing an increase of the species, which I believe is due to mostly to this targeted funding to these sensitive species. But anyway, what we know about the species, what I want to show you is that actually most of the species in Kenya, we don't know because they have this least concern status that I believe that if we actually knew more about it, we would realize how badly some of them are doing. And this is just showing, a diagram of the number of species. If you actually look at the biomass, like how many individual of each species, then you will notice that these species at risk that we've considered are a very tiny proportion of the entire biomass of bird in Kenya. So answering the question of how all these birds are doing is actually really challenging. And there isn't a very simple data set that you could use at. And one of them that I think is very valuable is these atlas data. And for instance, in the US, the breeding bird survey, which runs since 1966, have been able to document a large decline in the number of species of bird, number of bird in North America. So more than 3 billion birds gone since 1970. And this atlas data, because they cover such a wide range, I mean, all of the species over a large spatial and temporal scale, they allow to actually assess species grouped together. So you could group species by, phylogeny or maybe some traits that they look together. And then you can assess not only how the species are doing, but also how the underlying habitat that these species rely on has been evolving. And they've been able to, show this way how grassland are actually deteriorating. And as a result, the grassland bird have been particularly declining. While, other birds like the waterfowl that have received a lot of conservation efforts have been increasing. So the breeding bird survey in North America is actually not unique, and many countries across the world have also had their own atlas data. In Europe with the European EBBA and EBB2, and many parts of the world. And what I wanted to highlight in this slide is how the a bird atlas of Kenya, the subject of today, is a very old atlas compared to the other atlas data. And that's a really interesting, data source that we have here, a very valuable one. And the other thing I wanted to highlight in this slide is the fact that since 2010, there's been a transition in the way we collect data, moving into online platform and mobile app. And I believe that these are changing a little bit the way we collect data, but also the way we analyze and how we perceive and how we study this evolution of abundance that used to be, this single snapshot every 10 or 20 years to now a continuous year-to-year fluctuation change in number of species. And that is changing a lot the way we can analyze this trend. But anyway, I also wanted to, take the opportunity to also highlight this summary work that has been done on this website, Birds for Africa, in South Africa, that list all the atlas data in Africa. And you can see there's a lot of them, actually. It's a really important source of data for Africa. And they're all pretty old in a way, or they provide really interesting data source from the past. And highlighting, again, this like kind of transition that we're seeing with Bird Map Africa, with which is a new platform where every citizen science can contribute through a mobile app to contribute data of birds they've seen on the ground, with the one in South Africa being the leading website, as well as Nigeria and now Kenya, and many more to come. Okay, so that was the introduction. Now let's look at the specific context of Kenya and what we've been doing with this old atlas and new online platform of data. So on one side, we have this old atlas data. I'm just going to highlight a little bit some of the key presentation of this atlas. It provides for each of the 1,065 species a distribution map and some description text. And for each of these maps, we've seen the presence of the species over 14 years, from 1970 to 84. Sorry, that's an error. It's actually a 55 by 55 kilometer grid. And for each of them, we have a presence only, so no abundance, no, how common, how many of them, or something like that, which is like whether the species was observed or not during these 14 years. So pretty basic. But they did record breeding evidence, which we actually not using in this study. But in the past, they used to record that. It seems like it was an important piece of information that we're not really gathering anymore, or not with the same degree of effort, at least. And maybe I'll just mention that about the digitalization of this atlas. We spent quite a bit of effort building a software to recognize the image of this map, to be able to digitize them and have the actually underlying data set, and publish that as a GBIF data set. And the reason why I mention that is that afterwards I realized that actually there's been at least two papers that have been using this atlas data, and they must have done the same effort somehow, but they never published the data set. And I think it's kind of funny how we, maybe sometimes repeat the same effort over and over. And so I would really encourage you, if you can, to publish your data as a separate from the paper, and the data themselves without the paper, as a separate publication with a DOI, that people can use, and then you can actually cite it in the paper that you're using. But the data is there and can be used with proper metadata describing the data set. I think it's really valuable source of information in today's science. Anyway, so that was the old data. And for the new data, we're using a combination of the two main platforms used in Kenya, the eBird and Kenya Bird Map. And we're also limiting to these 14 years of the last 14 years to have a similar time range. So just to overview of the process pipeline in this figure, so we take a map of the species and then we digitize it, and then we get for each of these square a single 0 or 1. Was the bird there or was the bird not there? Oh, observed or recorded. And then on the eBird data, we have these checklists. Maybe I won't go too much into detail, but we have a single location for each of a list of species. And then we upscale that to the same grid square. And so now again, we're just lumping everything. So whether it's been seen like a thousands of times or a single time, it's observed. It's just a 1. And we do the same with the Kenya Bird Map card, whether it's an incidental or full protocol. You know, as long as it's been there in the square, then we report it as being there. We merge them by considering that a bird is present today if it's been seen in any of the two data. And finally, we can compare them. So the analysis is pretty simple. You know, it's like, has the bird been there in the past and is not there today, then that's a loss. If it wasn't there in the past, but is there now, it's a gain, green. And if it's been seen on both data, both in the past and in the present, it's a kept. So we have this like kind of 3 main category that tells us whether a species has been, you know, more abundant or more present now, not abundant, just whether the range has been, the range has been changing. Now you can notice this circle have different size. So I'll go into a bit more detail here. I hope it won't be too technical. If it is, just take a break or do something else on your computer, and then you can come back. I'll tell you when I'm finished with this complex explanation, but don't worry, it's not essential. Essentially, what the circle is telling you is how confident we are about the loss or the kept. And I'll just try to explain how we computed that. So we take the old atlas. They have this coverage variable that they provide in the book. We see essentially a measure of how many or what's the percentage of the species were reported over the total richness. So they try to guess how many species were present and how many species they've actually recorded there. And the way they do that, they just model pretty simply the number of species based on 3 variables: the altitude range, the type of water body, and the observer effort. It's a very simple model. I'd be surprised if that could fly through a paper today. And then the richness is actually modeled by assuming a maximum observer effort. And by doing that, they kind of try to guess how many species you would have guessed on this, you know, linear model if you were to spend like a lot of time on the field. And then they look at the ratio of how many of the species they observe versus the species that they would model should be present in that square. If possible, you know, we would have loved this observer effort variable, but that wasn't available. That's why we're using this coverage variable. So this is on the old atlas data. So I'm showing here the same data, just with a different color scale, but it's exactly the same one with this percentage. And then for the new data, what we're doing is a similar thing, but now we're looking at the total duration of observation. So we're summing the checklist, eBird checklist duration plus the card duration all together. And that gives us for each square the kind of equivalent of how many hours of field work has been done in each of these square. And what I want to show you in this slide is like how similar the two maps are, in that they both show pretty strong, better coverage in Nairobi and around, as well as on the coast. Although you could say that, you know, today we have lost a lot of coverage on the north and northeast specifically, mainly due to instability. But yes, similar pattern, spatial pattern, anyway, roughly. Now, if I show you the number of species reported versus the coverage, you can see that the more time you spend on the field or the higher the coverage is for the old atlas, the more species are being observed, which kind of is obvious, but it's kind of nice to see that both the new and the old atlas are showing a similar pattern of like the more you spend, the more effort you spend, the more species you'll observe. And so now we want to use that relationship to kind of assess how many of the change in the number of species can be attributed to a change in effort versus how many of these change are actually not due to effort, but the change of species. And so to do that, we're plotting now for each square on the map the difference between the coverage in the past and the coverage in the present. So now I'm showing the circle. So like, let's take this, red circle that correspond to a square, a square on the map that in the past had like a 50 to 75% coverage, but today only a 12 hour. So relatively like fewer hour in the field today relative, to the other. And so essentially what you're getting in this figure is like everything on the top left has been, fewer effort or less effort in the present than in the past. And everything on the bottom right is more effort today than in the past. And what's interesting is that these change in effort relate directly to the difference in number of species you observe. If you look at the difference between the number of species in the past and in the present, and that's what the color of the circle is showing now, it's kind of directly related. So all of them on the top left are roughly more red. You can see they're all more red. And then the bottom on the bottom side, then they're green. And so you can see, for this one, it's obviously that all these species that we've seen in addition, a lot of them have actually just been linked to the fact that we spend like an equivalent of 1 month in the field, whereas in the past they only had a coverage of 11 to 30%. So we use this information of knowing how the effort has been changing to actually account for some of the species change. Okay. This should be almost this last slide, but this is the same data, so you can see the total duration on the x-axis, the same thing. And now I've switched the category of the old atlas as different line or different color of the circle. And now you see here the difference in the number of species between the old and new atlas. And the reason why I'm showing this figure is similar to the other one, but that's actually what we're using. So we're fitting a linear trend with the change in the number of species for each category of the old atlas coverage with the total duration. And that helps us to predict in a way what is the difference in the number of species we would expect based on a given coverage of the past and a given effort of the present. So let's say, you take, I don't know, maybe this circle here. And you can look at, okay, this circle belongs to the category 50 to 75%. So it should be on this dark blue line here. And it had an effort of 1, 2, 3 weeks of data. So actually, this is a bad example. Let's take this one, sorry. So this one here, so it has 1 month of data in the new atlas and a category of 11. Oh, that's actually the same one as we used before. Anyway, but that's good. Based on the model, what we would expect is that on that square, we should have a plus 100 species. That's the line here, the same color as the dot here. We should expect 100 more species on the square just based on the change in effort. And what the data is showing is we have a change of 140 species or something like 130 species. So what this tells us is like among these 130 species more we've seen, we can expect that 100 of them are linked just to effort and 30 of them are linked to an actual change in the number of species on that square. I hope that makes sense. If not, it's not a big deal. What you need to know is that we're using this model to kind of assess for each square the change in effort, how much the change in effort is affecting the number of species change that we see. And the point of doing that is that we can then plot with a circle, the size of the circle, which of this square we can be confident into the change we're seeing. And with the calculation I'm not going to show here, we've actually defined a threshold of certain criteria of like the minimum effort or change in effort that are required to keep the square. And all the dark square, we've eliminated them from the analysis thinking that basically the data is too bad, or at least there's too much effort influence into the species observed, that we're not confident that we could use the distribution here. So we've eliminated quite a big chunk of the square here. And on top of that, for the remaining one, we can quantify for each of the gain and loss, whether we're confident or not. And the way we do that, now this is the part that get a bit confusing. Before we said, like, the size of the circle is telling you the change of effort. Now, if you think of it, a change of effort is affecting the confidence differently, whether it's a loss or a gain. And that's why you get this reversal of the size, that if you loss, then a smaller, less effort change, a change of effort that has been less, correspond to an unlikely loss as well, at the same time as a likely gain. Because, if you see a species and you spend more time, or less time, sorry, then it's a very likely gain, whereas it's a very unlikely loss if you lost that species. I don't know if that makes sense. Anyway, the point is the size of the circle, when you see on a map, is giving you the confidence, not the change of effort, so that if you see a small circle, it's not really reliable. Whether if it's a big circle, it's reliable. Whether it's a loss or a gain, that doesn't change. It just shows you the confidence you can get into this data. Yeah. And and what we could do also is, like, based on this, thresholding of the map, we also can assess absence of the species. We can also assess that we actually spend sufficient time that we would expect the species to have been there, or that we would expect to have seen the species in either of the atlas, so that we can also say, well, actually the species is not present in any of these square, kind of for sure, compared to the other one where we just don't know. Okay, so for those that have dropped this complex explanation, I'm sorry for that. I'll try to get back into the result, which should be easier to understand and a little bit more fun. So the main result that was produced from that was this website where we show the distribution range for each of the species. And to present the website, I'll share the link on the chat, but I'll just play a small video that was made by Sam Guchu and Amélie Nussbaumer for introducing the website.
For the first time, all this information is available at your fingertips on an interactive website. This public platform is meant for conservationists, researchers, and anyone interested in learning about birds in Kenya. You can explore the changes in distribution in two views. In Grid View, you can zoom into a specific region and find out what species have appeared, stayed, or disappeared since 1970. You can also select multiple squares, broaden your area, and download a list of species for that area. If you are interested in a particular species, go to the species view and type in a species to browse its map. You can also choose to sort species by how much they have lost or gained range, or use filters to narrow your search to certain species group only. For each Kenyan bird, you can learn about their migration and conservation status, and access quick links to learn more about the species. You can also download each species map as an image. Get started today. Explore the platform to learn more about the birds around you, and join thousands of other citizen scientists recording data every day through the Kenya Bird Map project.
Nice. That gives me a bit of a break. Actually, it's a good idea.
For the first
okay. So now getting back into the results, just trying to look at three main kind of output that we add from the paper, looking at the species distribution. So we looked at all the species and we mapped for each of them the change in the total number of square that was lost or gained. And you see here along a phylogenetic tree for each of the species. So each of the branch, each of the kind of end of the circle correspond to different species. And the more close to each other they are, the more closely they are related to each other. So the species from the same family are often next to each other, and that's measured by genetic diversity. And so what I like about that figure is that we could use that to actually kind of go through all the species. And if, like me, you're a birder, you kind of want to know for each of these species what happened with each of them. So I'll just try to run through quickly some of them. So the first one on the kind of older species are the waterfowl, and you can see that they're kind of declining. Although if you look at the top of it, you can see a bit more increase for some of them. We'll get into that in a minute. The doves and pigeon, pretty increasing. The very steep increase here, very dark green, are the swift, and that was surprising to me, but actually making sense with urbanization and everything. But yeah, all of the species of the swift have been a little bit increasing, or a lot increasing for some of them. The wader, it's a difficult species because it's such an habitat specific species, so they're usually on the coast or something. So the range change is usually not super obvious, even though maybe the abundance has been changing a lot. So that might not be the best data, but still we see a decline in the species, and that's kind of what we expect for waders. But arguably a smaller decline than what I would probably expect the waders to have done. Here are the Ardidae, the heron egrets, so this kind of white waterbird that feels like they're doing pretty well. And then there's very steep decline in the vulture and scavenger. So vulture has the dark red, and the one around are the scavenger. All of these family that I think we all kind of aware about their decline. And so just looking at the range, 40%, 20%, and this is just the range. So you can think that for this type of vulture, the abundance is much more drastic decline than what we've seen, but that's already kind of a big issue. But it's what I find kind of nice is when we see expected result there, it's at least they all receive higher IUCN status, which I think is good. That means we were able to identify that was a challenge for these species. Then if I continue, the owls declining, also kind of expected. The rollers, very small here, not many of them, but also declining. The kind of bee-eater and related species like insectivore feeding birds, generally increasing. The very steep green are bee-eaters. Now, a pattern that we see is if you look at the rest, like the red one, I'm going to highlight the red. There's a lot of green, but the red one has here is the Palearctic shrike, the warbler shrike, the warbler, Palearctic warbler, sorry, and here are the wheatear, also most of them Palearctic migrant. And you can see that trend of all the red ones here are migrants. And then if I continue, there's a lot more green with the weavers seems to have, increasing their range, as well as the sparrow and related species. So pretty positive trend on the end of the taxonomy spectrum. Now, highlighting, getting back in, so one of the results we wanted to highlight here was this kind of things that when we put species together in family and we rank them by the species that are doing the worst to the species that are doing the better, what we've noticed is all of the one on the top are generally Palearctic migrant, and here in this case, just for the ducks and geese. And all the one on the bottom are all residents, generally bigger bird, all resident, and there seems to have increasing a lot more. And that was an interesting pattern that we actually observed, not just for the ducks and geese, but for a lot of species. So this is the same information. Now what I've done is for each of these family, I grouped together the species of the family that are Palearctic migrant in orange and the resident in purple. And what you see is the average change for each of these two groups. And here, highlighting the same thing I said Palearctic migrant, pretty steep decline of 20% decline in average, whereas the resident, slight increase of a few square. And now if you look at all the family, this trend is kind of consistent throughout all the family except the top three one, falcon, oaks, and bee-eaters, where, maybe the migration is not really the best way to separate them. But for the rest of them, we always see this clear trend of saying if you're a migrant, you decline, and if you're a resident, you increase either a little bit or quite a bit more for this kind of Sylvidae warbler or reed warbler. So that was a very interesting pattern that we could confirm across all the spectrum of families. So it wasn't just one Palearctic migrant, but regardless of what species you are or which family you are, if you're a Palearctic migrant, you're doing worse. So that was the kind of second result. And then the third one is about these species. I don't know if you can pick up on like the kind of common denominator between these three species that maybe some of you know. Give you a minute. It's actually they've all been increasing quite significantly, among the biggest increase, and they're all introduced species. It's actually, in a way, it's relatively small number of species. I was surprised, when I think of in Europe, we have a lot of introduced species, and in Kenya, there was only 4 of them. But still, these 4 species have really been increasing a lot. Like this house sparrow is quite incredible. It's hard to believe that in the past they were kind of at the level of the house crow, and now they're just everywhere across the country. So again, showing this kind of change of like urbanization and human have definitely been influencing the distribution of these species. Okay, so before finishing, maybe just highlighting very few limitation. It's always a bit challenging to finish with that, but we talked about it's important to really take into consideration the scale and data type that we have, and that's this data analysis not to the level of maybe modern trend analysis, in a sense of like we're really looking at chord scale range change rather than abundance, and that is a big limitation. And we cannot just equate the two of them with a martial eagle having like 5 or 6 pair in a square versus just a juvenile martial eagle flying by in one of these 14 years. That has a huge difference in the impact of the bird has on his community, while in our analysis it would just show as like kept as like both of them being present. So a good knowledge of the bird movements is really necessary to be able to analyze all of these maps. So you cannot just take the map as the truth. You have to kind of think a little bit more through to kind of think of the impact that the data has on the pattern you see. Now, the change of effort, we try to account for it, but it's not a perfect one, right? I mean, today we have surveys that are much more structured to make sure that the effort is more similar. We've just done a really kind of course level accounting for the change of effort, but really a lot have been changing, both in terms of equipment and also identification, with new species describing or taxonomy being changing. And also, the way you can move across the country has been changing. And the number of observers, they were 200 in the past, and now we're like several thousand observer in the present data set. It's just a very different landscape of who is observing birds, which I think is a great thing, but it does impact the data. Okay, to finish, I think beyond like the core result, the thing that I'm the most proud about this project, I think, and the way it's been run is like it was really a collaborative effort with these 3 main organizations, Arusha, Kenya, and Colin Jackson, the Museum of Kenya, and Tropical Bird Association with Korea, and they all been investing a lot of their energy, and Peter and Njoroge for the Museum of Kenya to really take and own up the data, because they are the main one that have been working on this new Atlas data, citizen science Atlas data, KBM, and to really take that data and bring it to the level of researcher and policymaker. And here was the launch event with the Director General of KWS, if I'm correct. So pretty big guy coming to the launch event. So I think that's really great, and that's thanks to their effort, and they've really did a really good job at using that data in a way that makes sense and is useful, not just for small paper publication, but also really for people in the field there and decision maker. So I've started asking the question how Kenyan birds are doing with the change in the landscape. And I believe that this project provide a kind of first order of magnitude, with some of them increasing, you can see here with this green arrow, some of them being pretty stable and other declining. And I'm not going to hide behind the important limitation, and that I would really stress that a careful reading of each of the map is necessary. But this is, I believe, the best I could do with the data, at least, and I think it does offer some first suggestion of what species we should focus on, or kind of detail some new pattern that we can study more now. So I'm excited to see how this data set and these resources will be used in the future. by policymakers, but also by conservationists in Kenya and other scientists in Kenya. And to finish, there's a lot of people behind this project that now I feel like I should mention all of them. Like you can see some of the name in the authorship of the paper, but really thanks to all of them, and thanks a lot to all the citizen scientists that are contributing to their data every day. They contribute to their free time, and that's really a helpful and useful data set. So thanks a lot to them. And yeah, to finish, make sure you visit the website when you have some time later on, and feel free to send me any feedback if you have some. Thanks a lot.